example 12, we are going to learn how to use trigonometric identities to solve equations. And we are expected to solve 4 cosec squared theta, and this is where we are going to dwell around. Minus 9 is equals to the cot theta. And you realize that from what we have on the right hand side of the board, it is possible to express cosec squared theta in terms of cot theta. At the same time, it is possible to express cot squared theta in terms of cosec squared theta, which is going to be cosec squared theta minus 1. In the meantime, we have cot theta, and from this particular equation, we are going to have cot squared theta. So it is not easy to take that route. At the same time, we are going to have sine over a cosine over sine, which does not really work with cosec squared theta. So the easier thing to do is to express cosec squared theta in terms of cot squared theta. And what do we do? Expressing cosec squared theta in terms of cot theta, we're going to have 1 plus the cot squared of theta minus 9 is equals to the cot of theta. And what we have here is 4 plus 4 cot squared theta minus 9 is equals to the cot of theta. And if you look at this general equation, it's suggesting that it's going to be a quadratic equation, and therefore we would rather have everything on the right being equals to 0 and have 4 cot squared theta minus cot theta. 4 minus 9 is going to be minus 5 is equals to 0. And at that point, it is clearly a quadratic equation. Fine. We may have to bring in another unknown, which we can say, let y be equals to cot theta. That way, we are going to clearly see how is it a quadratic equation. Therefore, it changes to 4y squared minus y minus 5 is equals to 0. And with this, you can have now the factorization method, the B and AC approach, where our B is -1 and our AC is minus 20, because you can see 4 times minus 5. So two numbers which we multiply, they give us a minus 20, and we add, they give us a minus 1, is basically a 4 plus a minus 5, and vice versa. And a 4 times minus 5. So if we substitute these factors into the middle term, we are going to have 4y squared plus 4y minus 5y minus 5. We're going to get 0. Okay, in the first two terms, 4y is common, so 4y, open bracket, y plus 1 minus 5, which is common, no y, plus 1 is equals to 0. And therefore we have 4y minus 5, y plus 1, all this giving us 0. And either of this bracket can give us a 0, and therefore we may have 4y is equals to 5, and in this case y is equals to 5 over 4. Or y is equals to -1, and that is it. But remember, what was our y? Our y was cot theta. So if this is true, cot theta is 5 over 4. That means in the calculator, we may not be able to readily work with cot, so we are supposed to work with the primary trigonometric ratios, which is, and this one is so much related with tan. And of course, what is cot theta? Cot theta is 1 over tan theta, which is 5 over 4. This one already tells us that the tangent of theta is 4 over 5. And that is one solution. We have not yet been able to get the value of theta, but we can already see that the tangent of theta is equals to 4 over 5. If you use this y is equals to -1, again we are simply saying that the cot theta is -1. And this takes us to that 1 over the tan of theta is -1, and clearly shows that the tangent of theta is 1 over -1, which remains -1. So we are going to work with this, and we are also going to work with this. There are two possible angles. But let's see. If we take the tangent of theta to be 4 over 5, we are going to talk about unit circle, whereby when the tangent of theta is 4 over 5, we need to identify what is really 4 over 5. 4 over 5 is equals to 0.8. So if we talk about shift tan of the answer, we are going to talk of 38.7 degrees. And since the tangent is positive, theta is supposed to be 38.7 degrees. So we are talking about 38.7 degrees. And if you follow the slogan, all science teachers complaining, we are going to realize that the angle theta is in the first quadrant, because in the first quadrant tan is positive, and it is also in the third quadrant, so 38.7. So in this case, if this is true, then our theta is 38.7 degrees, and our theta, this could be theta 1, this could be theta 2, is 180 plus 38. 180 plus 38.7, which is going to give us 218.7 degrees. Let us just be sure of that. 218.7 degrees. And that is just when the tangent of theta is 4 over 5, or rather 0.8. What about when tan theta is -1? When tan theta is -1, again we go to the unit circle, and we know that the tangent inverse of 1 is 45 degrees. But you can see this one is already negative. You can see that is already negative. So if we talk about shift tan of 1 is 45 degrees. But you can see already, if all science teachers keep complaining, you can already see that theta is not in the first quadrant. Theta is not in the third quadrant. Theta is going to be in the second quadrant, because in the second quadrant tangent is negative, and theta is going to be in the fourth quadrant. So if we talk about 45 degrees, of course it doesn't exist there, but you're going to talk about 45 degrees. Remember the angle between the line of angle and the horizontal x-axis. So it's going to appear in this quadrant and also in this quadrant, because then this must be 45 degrees. So if that is true, then theta is 180 minus 45. Theta is 180 minus 45 degrees, which is 135 degrees. At the same time, this could be theta 3. We are going to talk about theta 4 is 360. Is going to be, again, it can be 360, but we are 45 minutes shy from 360. So 360 minus 45 degrees, which is 315 degrees. So yes, we have been able to get the value of theta. If we line up all the possible values of theta, we're going to say theta is equals to 38.7 degrees. It's going to be 218.7 degrees. It's going to be 135 degrees. It's also going to be equals to 315 degrees. So all these are possible values of theta. And it is important that you exhaust all of them depending on the arrangement of the original relationship, so that you get full marks in such a question. All right.